Good evening, good evening, good evening, good evening to all the grade 12 students. The new batch of 2024-25. How are you all doing, students? Yes, those are watching me for the first time. This is your Vani ma'am, as mentioned here. And let me greet all of you with a smiley. Yes, how are you all doing? Nothing to worry. Vani ma'am is there with you all for the whole academic year. Yes, so 2024-25, as mentioned, I'm there for the grade 10 students, I'm there for the grade 11 students and grade 12 students. So as mentioned, we have started the series, and that too I have started with your solutions chapter. Yeah, because we are going to study according to new examination pattern, correct, right? So new exam pattern where competency based questions are 50%. So I'm going to follow the new exam pattern where we'll be solving questions and questions and questions. Let's start the video. In the last session of the last video, I did a topic called types of solutions. So, okay. So day one, I did types of solutions. So along with the MCQs, I finished MCQs and types of solutions. So I hope you have taken a book, noted a book and just written everything. Now today our task or the target is to do what? Expression of concentration. Yes. So expression of concentration of solutions of solids and liquids. This is what we are going to learn today, and especially we are going to do numericals. Yeah, I'll be doing the numericals. So carefully watch the video and note it. Let us not waste time. Let's start the topic. All right. So first of all, expression of concentration of solutions of solids in liquids. Okay, they said a solid is dissolved in liquid. Okay, I have two test tubes. What are you observing? This is test tube 1 and this is test tube 2. What are you observing here? In test tube 1, there are two particles. One, the red one is a solute particle which is present in the lesser quantity. This is solute. This is solute as mentioned. The black color ones are solvent particles which are more. Yeah, now in this case, solute particles are more and the solvent particles are less. Am I right, students? Yes. Now, every time what we should understand, basically, solvent is always present in larger quantity. That is a common assumption. Solute is present in the smaller quantity. That is a normal assumption. Now, today we are going to understand actually the concept of concentration. What actually is concentration? The first important thing to understand, if I have to define concentration, ma'am, what is concentration? Why we are talking about solvent, solute, in few it is more, in few it is less. So normally maximum thing or maximum in nature, if I have to see this test tube and talk, here solute is less, correct, right? This is solute is less. Solute is when solute is less, that means the solute is less means the particular test tube has more of water. Correct? Just like salt. If more of water is there, means it is called a dilute solution. Once again, if the solute is less indirectly, solvent is more. Correct, right? Is my right? Okay, solvent is more. When solvent is more, that is called more of dilute solution. Okay. In nature, do we find such solutions? More? Tell me, do we find everything? No, we are mixing everything. Everything we are mixing and adding sugar solution, salt solution, water, everything like different, bleaching powder, everything we are adding more of solute. So basically, in nature, we don't find such dilute solutions mostly. Correct, na? The solution. So how should we study? So basically, we have to understand what actually is meant by concentration. Concentration means simple. If I have to write the definition is amount of solute. Okay, amount of solute. Where is solute that has been dissolved? Dissolved. Where is it dissolved? Dissolved in given amount of solvent. Amount of solute dissolved in given amount of solvent. Correct. Now, this given amount of solvent, we said in this earlier case it was less. In this earlier next case it is more. How should we define? So normally this concentration, whatever amount of solute or dissolving, we study in terms of two things. First, if it is dissolved in less quantity, more quantity, what as quantitative and qualitative. So understand, we study it as qualitative study. Qualitatively we study and quantitatively study. Okay, quantitatively. What is this, ma'am? See here. Qualitative study means in this case the solute is less. Solute is less in this case. Qualitatively the solute particle is less. Alright, so that means it's a dilute solute. Quantitatively, the solute particle is more in this case. Alright, so concept we are going to study most quantitative study here. Okay, so go back. So this is qualitative part, this quantitative part. We are going to study about this in this series. Let's start. What are the different ways of determining concentration? Concentration can be determined different ways. So the first topic we want to study is mass percentage. First, the mass percentage, volume percentage, parts per million, molarity, normality, mole fraction, parts per million, everything. Today I'm going to teach you about mass percentage, which is denoted by small w by double. This is your mass percentage. So mass percentage, first of all, how should I define mass percentage? Or what is the numerical I have to remember, and what it is we will understand now. Okay, so before we go into the sum, let us write the formula and see. Mass percentage, I said there are only two components. So write the formula. First one which is present in the quantity, mass of the solute. Okay, mass of the solute. I can call it as component also, mass of the solute or the component. Okay, divided by what is present, where is it dissolved in the solution. Correct? Yes, total mass of the mixture or compound. Total mass of the mixture or compound. Alright, students, that means in a particular test tube, whatever solute you are dissolving, that solute divided by the total mass of mixture or compound. That means basically we're talking about solution. Mass means nothing but the solution. So in simple words, what will I say? It is mass of solute by mass of solution into 100. This is 100. That's called mass percentage. Ma'am, can you just tell me an example? Okay, suppose if I say you have in this particular testimony, I will say 10% glucose, 10% glucose is there. That means 10% glucose means what does it contain? It contains by weight 10 grams of glucose is there in, it is dissolved in 90 grams of water. 10 grams glucose, it is thicker and it is dissolved in 90 grams of water. There's nothing but 10%. So overall, what is the total thing? 90% is 100. Solution weight is 100. Solute weight is 10 grams. Solvent weight is 90 grams. So to clear, if I add solution is 100 grams weight. This is solution. You got it? You understood this? Got it. So now let's do one sum and understand. Yes, let us see this question. Calculate the mass percentage of 10 grams of solute dissolved in 90 grams of water. Simple. How should I solve this? They ask me to calculate mass percentage. What is the formula I know? Mass percentage is equal to mass of solute divided by mass of solution. Correct? Into 100. Okay, this is mass percentage. Okay. So first of all, what is right? First of all, what is given to me? Given is mass of solute. How much is mass of solute given to me? 10 grams. This is 10 grams. Okay. Anything is given to me more quantity? Yes. This is like mass of solid is given to me. Mass of solvent is given to me. How much mass of solvent given? 90 grams is given to me. Mass of solvent. Perfect. Now what is mass of solution? Mass of solution, how much? To add solvent and solute. A plus B, and A plus B. Which is it? It is nothing but 100 grams. This is done. Now like the formula. What did I get? 10 divided by 90 into 100. Correct? How much do you get? Yes. Okay. So basically, now maximum students get confused when they solve numerical. They can have calculation. I don't have a video on how to do the calculation also. Very easy. Now I did a mistake. What is this mistake? This denominator is super solution, right? So mass of solute is 10. Solution is 100. 100 is cancelled, and I get 10 grams. 10 grams. This is the answer. So mass percentage of water is 10. That is what I asked. Mass percentage of particular solution. It is 10 grams. Easy. This is nothing but weight by weight. Oh, there is one more numerical. Carefully understand. There's one more question. In fact, let us question. I like the question. If you give me calculate mass percentage. Okay, ask me calculate mass percentage. Which one of benzene is a quite famous question. For benzene, what is benzene formula? C6H6. Okay. And one more solute is there. Carbon tetrachloride. Okay. What is carbon tetrachloride formula? C6. They give me right, and they give me if 20 grams of benzene, 20 grams of benzene is dissolved in 122 grams of carbon tetrachloride. This is what they have given. Okay. What should I find out? I have to find the mass percentage. You know the formula. So let's what is given to us. First, given to me. Is there anything given like when they give us total solution but nothing, right? So first we will find total mass of the solution. Because I need the formula. Total mass of solution. Solution is made of what? Solution is made of benzene. Solution is made of carbon tetrachloride. Carbon tetrachloride. How much is benzene weight? Benzene weight given is 22 grams. How much is carbon tetrachloride weight given? 122 grams. So the total mass of the solution now we have got 144 grams. This is done. This is over. Okay. Now I have to calculate what? I calculate mass percentage, right? So mass percentage formula is nothing but mass of benzene, mass of C6H6. You want to find stability first. Mass percentage of benzene, C6H6. Both the solutes are different. So formula is mass of solute divided by mass of solution 200. Correct? Mass of solution 200. And what solute weight here? Solute weight is 22. What is total mass of the solution? We already got here 144 grams. How much is mass percentage? So if I divide this, I get around 15.8. 15.28%. Benzene, it is nothing but weight. Right? This is mass percentage. Now what is the other thing left? I calculate for mass of carbon tetrachloride, CCl4. CCl4. What is this? Again, same formula. How much is carbon tetrachloride? 122 grams. Every grams. So that is easy. Divided by total solution mass 144 grams. How much is this? 200. So if we divide and get, we are 84.72%. Okay, this is weight by weight. Well, this is the sum. Look here. They asked me what calculate mass percentage of benzene. I did it. Calculate mass percentage of carbon tetrachloride. I did it. First I calculated total mass, then I calculated separately. That's the sum. Should we see one more sum? One more variety. Let's see. Sure. One more variety. This is question number 3. The solution is obtained. Is obtained by mixing 200 grams of 25% solution and 300 grams of 40% solution by mass. Okay. Now solution spread. So 20% solution, 300 grams of 40% solution. Which solution is 10? And what they asked me to calculate mass percentage of resulting solution. This is easy actually. Only formula you need to remember. Resultant solution. Let us calculate. First, when they give me, first of all, I have to calculate total mass. So calculate the total mass and keep it total mass. How much is total mass? Here. 200 grams is 1. 300 grams is 1. So add 200 grams plus 300. How much is this coming to? This is coming to 500 grams. Right? 500 grams. This is over mass. Okay. Now, first thing, this is over. Next, they ask me 200 grams of 20%. I know the solution. So I write amount of solute present. So I'm taking the first because I know the solution, right? Amount of solute present. What did they say? They say amount of solute present. 200 grams of 20%. 200 grams of 20%. How much is the 25%? It's 2500. Okay. 2500 equal 200. Right? Right? How much will come to cancel these two? Cancel these two. 25 to 50 grams. This is over. This is the first thing I calculate. Now what should I do? I have to calculate the second part of this. Calculate the second part of this. Let us say. Next thing part is amount of solute. Second one is there, right? Amount of solute in 100 grams. 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 40% of 300 grams. Means what? Means 300 grams into 40 grams. Calculate separately. Divide by 4 3 not 20 grams. So solute 1 is the earlier the weight. The solute 1 weight was 50 grams and the solute 2 weight was 120 grams. This is over. Done. Now, last. Total mass of solute both together. Because I have to find the mass percentage, right? Total mass of solute is equal to 50 grams plus 120 grams, which is equal to 170 grams. That's perfect. Perfect. Now finally, calculate mass percentage. Mass percentage is equal to mass of solute. How much is the weight? 170 grams. How much was your solution weight, which I got first? 500 grams. Okay, 500 grams and 100 percentage. So to cancel, then 170 by 5 is 34%. 34, so that's 8 by 8. Easy, simple. Calculate the total mass. Calculate solute separately. Total mass of the solute and find the mass percentage. Shall we do one more sum? Okay, last one. Let's do one more sum. So question. Let me ask you this is one more variety of sum. Calculate mass percentage of carbon compound. We are asking this question. How much is carbon? Take any compound, any compound. For example, let me take the common compound. I'm taking example methane. Okay, methane. So in methane, carbon is there, right? So in methane from what? Let us see. In carbon, how many carbon atoms are there? One. What is the mass? Atomic mass 12.01 gram. Oh, that means there is 12 gram. What is the weight of carbon in one carbon atom? One atomic mass unit of carbon present in methane. How much is hydrogen? Hydrogen, how many atoms are there? What is the atomic weight of hydrogen is 1.01 gram per mole. Is equal to 4 gram per mole. Right? So now total of solution. Let's take total mass of solution. What is total mass of solution? It is nothing but 12 grams plus 4 grams is equal to 16 gram per grams. Okay, 16 grams. Over. Now carry mass percentage. Mass percentage is equal to how much is it? Total weight plus your solute is so much. Solution is so much. Simple. 12 grams divided by 14 grams into 100, which is equal to 12 by 14 from 8.7%. That means in methane molecule, let us go back to for you to note it. So that means thus, you can do answer, thus mass percentage of carbon in methane is how much? Is 8.7%. That's easy, very, very easy. So basically, your mass percentage maximum concept we have covered. Alright, so mass percentage concepts are covered. I request all of you to please take a notebook. I don't know how many notebook. Try to get 400 pages notebook. We have more questions right over here. So please open this notebook, label the chapters for whatever are there. So in this first table, I did types of solutions I use. It's for solutions MC uses what I did. Now next thing, what did I do? I did mass percentage numericals. Correct now. So I request all of you to please like the video, like the video, and share the video, and give me valuable suggestions or comments so that I can further proceed in this. One human always believes in only one word. Yes, what is that? Work till the last drop of life. Yes, without expecting anything. Only you are not expecting anything. Only thing you do is share the video. Like the video, like the video. So I'll come back next video with 1 percentages. Thank you so much. Thank you.